Zoe to follow those two excellent talks. So we're going to talk about regenerative medicine, and Zoe's talk is sort of one of the hot watchwords at this meeting, and I think it's here to stay, not just something that we're going to hear about on a very temporary basis. These are my disclosures. So the agenda will talk about some new generation cosmeceuticals this year, ongoing trends including the microbiome, clean beauty, and personalized skincare, which is extremely important. There is not one skincare regimen for all individuals. We have general recommendations, but we really need to individualize our care. And then some new and future delivery systems that can optimize the efficacy of all the products that have been talked about. And then we'll talk about what are the next steps in the future. So again, as has been just talked about previously, this is a protocol that I follow for my patients. In the morning, it's basically about protection, hydration, and in the evening, it's interventions and strategies that induce cell turnover, again, collagen and pandermal matrix stimulation, pigment reduction, and erythema reduction. So these are products, when I choose my regimen for my patient, these are the basic principles that I follow to achieve those goals. So peptides and cosmeceuticals is a hot term right now as well. And the reason for that, there are some excellent, again, clinical properties of peptides. There are various peptides, but they all have some commonality in terms of their efficacy. They're signaling molecules. They, again, induce signaling between cells and between the skin barrier and cells as well. They're collagen boosters. It's been shown from a number of studies. They increase collagen formation when used for at least 30 days or more. And subsequently, they can reduce fine brightness on the face. And they, what I think is really important and underemphasized about them, they have strong anti-inflammatory effects. So I'm a big believer that inflammation is a major cause of the aging process and of skin cancer. If you can reduce inflammation on your patients in your skincare regimen, you probably can improve or slow down the aging process and decrease the propensity in utilization with a good sunscreen in the development of skin cancers. So in this study that was published recently, again with 30 participants, it shows using peptides on a daily basis reduced, again, their wrinkle, scores, as well as improved skin elasticity. And that's interesting. In biopsy studies utilizing peptides, not only can you get increased collagen production, but you get increased elastin production as well. So exosomes, the future of skincare. I know Zoe spoke in our course yesterday about this. This is sort of the hot area. It hasn't really been mentioned. But I think exosomes are here to stay, but they're still on the warming plate. They're not quite ready to be eaten yet. So I think that we need to stay tuned because they do play a number of roles if we think of regenerative dermatology as one of the major advances and movements in the future. Because they enhance cell communication. They are signaling types of vesicular properties. They have anti-aging regenerative properties as well. And in studies using topical products, even topical products, in some parts of the world, not in the US where it's not allowed by the FDA, they have been shown to have significant improvement in terms of the signs of aging, including wrinkle reduction and as well boosting neocollagenesis. And they're also enhanced delivery systems, and they can deliver multiple ingredients or almost any ingredient to the skin. But the issue with exosomes is we really don't know exactly what is the optimal concentration of exosomes that should be in skincare products. And again, similar to where PRP was several years ago, exosomes contain growth factors or cytokines or stimulatory and messaging properties. And we really don't understand which of these properties is most important in the exosome preparations. So be careful, because a lot of what's talked about is marketing and not evidence-based information at this time, but exosomes are here to stay. And the most efficient way, again, to utilize exosomes is in our own endogenous platelets. In PRP, where we now develop systems where we can actually, again, remove the growth factors which have the highest concentration for our own platelets in PRP. So you can see in this clinical study using a topical preparation, there was again significant improvement in multiple signs of photoaging after 12 weeks of improvement in wrinkle depth, again, skin firmness, and in texture. In my experience in working with exosomes only from platelets in our research lab at the University of Minnesota, I have found that topical application can improve skin texture, skin radiance, but it's too early, again, to recommend this for generalized usage. And the role of topical exosomes is even more controversial. I think if it's endogenous from your own platelets, Again, it sort of has a bypass through the FDA, and again, it has the highest concentration of exosomes compared to, again, other types of derivatives which are derived from other sources. So stem cell regeneration, that's the hot new area for me in 2025. Again, these stem cell regenerative capabilities can stimulate cell renewal, repair, rejuvenate skin, and have strong anti-aging effects. So there are a number of stem cells, as you can see here. I won't get into this in major detail, but they can be endogenous, they can be from plants, epithelial, mesenchymal, or pluripotent stem cells. But again, there are ethical considerations of why they're sitting in the FDA now and being looked at, and that is because, again, these adult stem cells, which convert over embryonic stem cells, have the capability to do signaling that could be associated with the development of cancer or other problems. So what has been, again, FDA approved, and what I think is one of the major advances in the future, is the isolation of stem cells from hair follicles. A company up in Toronto, an academic institution, I won't mention the name, is now able to, we're able to obtain and culture hair follicles from a source of diverse cells, non-invasively, just by pulling out some hairs from the scalp. And this is an ideal source of stem cells and keratinocyte stimulation. So there are a number of studies now being carried out, including from our research group. So the major, again, product here is called the secretome. It's derived from stem cells. And it's a diverse array both of growth factors, cytokines, exosomes, and mesenchymal matrix molecules as well. And it appears from the initial studies that have now been published that it has 34 more times growth factors than in simple PRP preparations. So this is sort of the new kid on the block, so I think you're going to be hearing a lot more of this, or several publications now in process about the secretome as a major source of growth factors and mesenchymal stimulatory type cells. So here's the secretome, how it's derived from stem cells. What you do is you just do a plucking of about 50 hairs from the posterior part of the scalp. They're expanded out in culture. There are 2 culture sites in the United States, again, for about a month. And then as you can see here, you have up to 100,000 cells that can be collected and conditioned. And the first products which are now being used for anti-aging are now being derived autologously from your own, again, stem cells, again, with delivery of the secretome type of product. And the next is going to be for hair growth, again, but the initial studies that are now ongoing for anti-aging, it appears to improve all the qualities of aging utilizing this product, but the real goal is for it to be a trichostimulatory agent in the future, and those studies are about to start. So here is a study that's ongoing again, looking at the symptoms of aging after procedures, after post-procedural use, and again, it's personalized secretomes. It's your own, again, growth factors that are derived from your own hair follicles. So this is what's called personalized skincare. And again, that the number of cytokines in these preparations is extremely high. And here's a clinical trial ongoing at our research center again, where we're looking at for hair growth, scar improvement, and for skin rejuvenation. It's just starting. The first products that we're looking at is for skin rejuvenation. But I think this is going to be a major advance in skincare in the future. It's secretomes, autologous isolation of these skincare products. So what are the new, again, other new trends that are talked about? Salmon sperm, which is felt to have a DNA repair capability and some effect on collagen synthesis. I'm not a big believer in this entity myself. I think most of it is just, for me, is just marketing. I'm a pretty scientific person, as most of you know, and I only do things based on evidence-based, but this is the hottest thing in New York now and in Hollywood. Again, salmon sperm facials, but again, I don't think there's really any significant evidence-based information that it's really effective. This is more of a marketing type of issue. The mechanism of action here, as you can see here, is felt to have an effect on DNA modulation and to induce angiogenesis and to have strong anti-inflammatory and proliferative types of effects. But I would be very careful of this. As you see it, patients are coming in asking for it all the time, but there is no excellent scientific proof about it. So again, in this one sort of soft study that was done, there was some improvement in photoaging, but in my hands, looking at and trying a couple of patients, I didn't see any efficacy whatsoever. So the microbiome now, we know this is a skin inner ecosystem again, and the goal here again is the fact that inflammation for me is a major source of what causes aging and skin cancer and hair issues such as hair loss as well. So you want to keep your microbiome in balance, okay? So products that are utilized should have some effect on balancing the microbiome, and this is part of, again, individual skin care. My associate, Dr. Rudas here, has been doing a number of studies on the microbiome in terms of its utilization for hair growth, as well as for, again, photoaging as well. So I think that a balanced microbiome is really a major, again, goal in the future. So as you can see here, probiotics also is something that's talked about. It's felt to have significant barrier protection. There are several studies looking at improving the skin barrier as well. So I think that, again, probiotics will have some role. And finally, just a couple of other areas. Clean cosmeceuticals, the new standard, that people want these eco-friendly and minimalist type of formulations. So again, this is somewhat more of a marketing issue for me rather than an evidence-based issue, but clean cosmeceuticals is something you may hear about. This is something that I think is important, and that's the delivery systems for all the products that we utilize. So again, there are certain products that are difficult to deliver, and again, liposomes, encapsulated liposomes are a way to have larger molecules, have transepidermal penetration, and can be effective. Nanoparticles are smaller particles, and a lot of us are using energy-based devices prior to using skincare products or microneedling, again, to be able to increase transcutaneous movement. Artificial intelligence in cosmeceuticals. We're on the verge now of an advance, and we're in the early stages of artificial intelligence. Again, our research group is working on a new artificial intelligence device for training, utilizing skincare products and for fillers and toxins. And I think you're going to see more consultations and more clinical studies using artificial intelligence to evaluate the results of products. So in summation, Zoe and Patty Ferris here and Mary Lupo, we've published several books on all of this. I think the future is very bright. We have new trends, but the goal is, remember, in the morning is protection, in the evening is cell turnover, dermal matrix stimulation. We're going to be hearing more about exosomes, I'm sure, in the future, and I think that these culturing techniques of our own cells really is the major goal as we move forward. Thank you very much.
Concepts in skin of color. And we want to cover broadly cosmeceuticals from every aspect, and I'm so thrilled that she's going to speak to us on this topic. And at the end of the talks, if you want to come to the microphone before, that would speed up our question and answer and get as many questions in as possible.
Okay, good afternoon, everyone. So today I'll be talking about cosmeceutical concepts in skin of color. These are my disclosures. So our skin of color patients have abundant melanin, and of course having a lot of melanin in your skin has major advantages. One of that is it delays certain signs of photoaging. Not all photoaging, but certain signs. And then the disadvantage is that we see a lot of these pigmentary disorders. So in skin of color, photoaging presents as uneven skin tone, solar lentigines, post-inflammatory hyperpigmentation, then we see other things like melasma, and it can be a big problem. It's what I do every day in practice, and we're going to jump into some really novel treatments and get you up to date on what's new to treat hyperpigmentation. Before we talk about that though, I want to talk about how skin tone influences perceived age. So this is one of my favorite studies because they took these digitized photos of real people and then they left the topography of the skin the same. That means they left the fine lines and the textural changes the same, but they altered the amount of pigmentation on the skin. So they made the skin more even and less even. And then volunteers or participants in the study graded how old they felt each of these digitized images were. And simply skin tone unevenness accounted for a 20-year range in the perceived age. That means the same person, when you made their skin more even, they could be graded as young as 17.8 years old. And that same image, when they made their skin more uneven, they could be graded as 36 years old. So our patients are really concerned about hyperpigmentation and uneven skin tone, and this is why we really determine how old someone looks by how even their skin tone is a major factor. So there are many new agents for hyperpigmentation, and we're going to touch on some of the newer ones today. And let's jump right into it. So we're gonna talk about human tyrosinase versus mushroom tyrosinase. So all of the tyrosinase inhibitors that we've been using for all of these years, like azelaic acid, kojic acid, they have been tested on mushroom tyrosinase. And mushroom tyrosinase is actually quite different than human tyrosinase. Human tyrosinase in assay didn't exist. It was recently discovered, or say in the last 10 years discovered. And thiamidol is an inhibitor of human tyrosinase. So this is kind of a busy slide, but I wanted to show you the difference between human tyrosinase inhibition, because we think of, for example, hydroquinone as a potent inhibitor of tyrosinase. It actually isn't. It's actually melanotoxic. But when you look at it against human tyrosinase, you can see here on your left, the strongest inhibitor, of course, of human tyrosinase in this study is thiamidol, followed by 4-butylresorcinol and kojic acid. But you can see hydroquinone is all the way down at the bottom with those little squares. And then in a model that looks, it's called melanoderm model, but it's a model that looks at pigmentation, and you can look at how pigmentation is inhibited. You can see that thiamidol, again, in this study, was the best inhibitor of melanin synthesis, followed by hydroquinone early. If you look early, hydroquinone kind of levels out, then 4-butylresorcinol and kojic acid. So the important take home here is that human tyrosinase is different than mushroom tyrosinase, and things that we have traditionally considered tyrosinase inhibitors have only been tested on mushroom tyrosinase. So we're gonna have to rethink, in the future, these tyrosinase inhibitors, because we really are most concerned, obviously, with human tyrosinase. So this is one study comparing thiamidol 0.2% to hydroquinone 4%. It was in melasma patients. There were 50 subjects. And they used the thiamidol product twice daily and the hydroquinone just at night. And in this study, there was no difference between the groups in the MASI score and the melasma quality of life and colorimetry and in the global scores. So it was basically equivalent to hydroquinone 4%. And this is another study that looked at thiamidol against 0.2% against hydroquinone 2%. And this study actually outperformed the hydroquinone, and you can see the before and afters, classic melasma, the top patient on the cheek, and significant improvement at the end of the study. Now, another very innovative, unique ingredient to treat hyperpigmentation is 2-MMG. This has a unique mechanism of action. It works by binding and inhibiting melanin precursors. So we've been talking a lot about tyrosinase. Tyrosinase is, of course, that important enzyme, the enzyme that we're most concerned about when it comes to pigmentation. And tyrosinase causes the production of pheomelanin and eumelanin. But we have all of these precursors that are highlighted here in orange. So DOPA, dopaquinone, DHICI, DHICA, and DHI. And how 2-MMG works is that it binds those melanin precursors. So all of those precursors like DOPA and dopaquinone and so forth are bound, pulled out of this process, and you get reduction in pheomelanin production and eumelanin, which is the one we're most concerned about when we talk about pigment. So this is just one study, and there have been many studies, posters. This one is published in the literature. This is a small study, 32 subjects, but what's interesting about this study is twofold. One is they looked at Fitzpatrick skin types 4 through 6. That's really important because a lot of times in the past, we would see studies looking at products for pigmentation in Fitzpatrick 1 through 3, and we all know it's significantly more challenging to treat our darker skinned patients when it comes to hyperpigmentation. So they chose the toughest patients. The second thing they did is the patients were not using sunscreen. This was done in a tropical climate in Mauritius, so you get you can actually see the benefit of the product alone, which was the 2-MMG serum used twice daily. So the reason why it's important that they didn't use sunscreen, it was kind of bold of them to design the study this way, is because we heard when Josh presented that sunscreen alone improves skin quality, reduces pigmentation. So they wanted to actually test the efficacy of the active itself, just the serum itself, nothing else, just cleanser and serum twice a day. And in this study, there was a significant decrease in the PAPI score. That's a measure of pigmentation. It was a 15.8% decrease in the PAPI score. And this is just showing you that from day 0 to day 84, this reduction in the PAPI score in patients in a tropical climate, not using sunscreen and only using the serum. You can see the patients at baseline and at day 24. On the patient on top, look at her forehead, which has cleared up dramatically, and also on her central cheek. And on the patient on the bottom, you also see significant improvement. Now, lotus sprout extract is another ingredient. It works via a different mechanism. It works via melanosome degradation. So this extract has been found in vitro studies to increase autophagosomes, which are these vesicles that kind of collect the melanosomes and take them away to be disposed of, basically. So it works via a different mechanism, which is melanosome degradation. And the product that was tested here contained lotus sprout extract, in addition to many other ingredients like tranexamic acid, which we know helps with pigment, niacinamide, and others, plankton extract, resorcinol, phytic acid. So in this study, there were 113 subjects with hyperpigmentation, but 44 of the subjects had also melasma. So it was a subgroup with melasma. It was a 12-week split face trial. So half of the face got hydroquinone twice daily, and half of the face got this combination therapy twice daily. And they saw similar results between the two groups. And that's also another bold trial because we typically don't use hydroquinone twice daily. We typically only use it once at night. So hydroquinone twice daily would have a very robust effect. And you can see that there's a significant reduction in the MASI scores and hyperpigmentation scores and an improvement in pigmentation. And these are some of the patients in the trial. The first patient you can see is an Asian patient with pretty classic melasma on the cheeks and improvement at the end of 12 weeks. And then you see a black patient, and look at her forehead. When someone walks in with that type of melasma, that very clear stands-on melasma, those are really challenging cases. I know I can get those patients better, but it's going to be an uphill battle, especially in Miami where I practice, where the sun is working against me. And so you can see she had really great results in this trial. Now, tranexamic acid is an ingredient that I just included because it tends to be sprinkled into many different formulas. So it generally is not used as a standalone agent to treat hyperpigmentation, but it is helpful, I think, as an adjunct. I think it's only used as a standalone in very high concentrations, and really most formulas add tranexamic acid as an adjunct. So it's been used orally, obviously, intradermally with microneedling, and then topically. But as I said, the big take home with tranexamic acid is I think it's helpful as an adjunct, not as a primary ingredient in most formulas. Now, cysteamine is an agent that has been around for several years, and I wanted to include this study because it was tested against the Kligman formula or triple combination cream, which is the most robust thing you can test an agent for hyperpigmentation against. Cysteamine works by inhibiting tyrosinase, but it also acts as a chelating agent for copper ions and iron ions, and those are cofactors in the tyrosinase reaction. So cysteamine has a few different effects. It's a multimodal. And this study looked at 50 subjects with epidermal melasma, and they compared 5% cysteamine to a modified Kligman with 4% hydroquinone, 0.05% retinoic acid, and 0.1% betamethasone. And they evaluated the patients at 2 months and at 4 months. And they had similar results, but there was a 9% greater reduction in the MASI score in the cysteamine group compared to the Kligman group. And those are the p-values there, pretty small p-values. So in clinical practice, we always say, the triple combination cream is considered the gold standard, but we do have several studies in the literature now comparing these alternatives to hydroquinone showing similar efficacy to the triple combination, which we consider the gold standard. Now, PATH3 is another technology, and it was validated through gene expression. So it's more of a combination of peptides. There's hexapeptide 12 and hexapeptide 11 that are involved in melanogenesis. This formula also contains lactoferrin that inhibits plasmin. It also contains phosphacetylserine and tranexamic acid. As I mentioned, a lot of formulas will throw a little tranexamic acid in there as an adjunct. And this study also looked at a nice range of Fitzpatrick skin types. So you can see that 3, 4, and 5 are represented. That's very important when you're looking at these because you want to understand the results. If it's only tested in lighter skin types, I'm less confident about the results. So I'm glad that they included darker skin patients in this study. And you can see that the brown is the combination PATH3 formula, and it did well for dyschromia over the hydroquinone. It did well for skin tone evenness and the MASI score. And this is one of the patients with significant lightening of that pigment on her cheek, and they even did some biopsies, which is very bold to do for a pigmentation study. Now this is something new that I think is relatively new. I haven't used it in my practice yet, but topical metformin has been used for melasma, and believe it or not, it's not that new because there's actually a meta-analysis published in the literature. So there have been a few studies, only 3, but 3 randomized controlled studies with a total of 140 subjects. And in this study, in this kind of review, this meta-analysis, one of the trials looked at 15% topical metformin and found that it reduced the MASI score compared to the placebo. So that's one trial. And the other 2 trials, interestingly, compared the metformin, it was a stronger percent, 30%, to a triple combination cream. And in that study, this topical metformin 30% had similar efficacy to a triple combination cream. So this is something that I personally haven't used, but my mentor programs has mentioned to me she does use this in her practice with good results. So it's something for you to consider, especially for your challenging patients. Melasma is definitely a challenge, and this is something that I'm going to add into my treatment armamentarium. Now, I can't talk about pigment without talking about visible light. Visible light, as you know, contributes to hyperpigmentation in our skin of color patients, so it's something we absolutely have to address. And this is an interesting study that might explain why visible light is so important for our darker skinned patients. So in this study, they were looking at melanocytes, and let me back up a little bit. I want to talk about opsins. So opsins are these light-sensitive G protein coupled receptors that are normally in our eyes, and opsins sense light in our eyes, in the back of our retina. But apparently, our melanocytes also have opsins. They have opsin 3, and they're expressed in melanocytes, and opsin 3 senses blue light. So the melanocytes in the dark donors in this study were more sensitive to the blue light compared to the light donors, and they turned on that when it sensed the blue light, this opsin 3 receptor in our melanocytes in our skin, it turned on melanogenesis. And this could explain why our darkly pigmented patients are more susceptible to the pigmentation that's induced by visible light. Now, if we want to protect against visible light, we need to use iron oxides. But this is a very interesting study that breaks down which iron oxides are most effective against visible light. So iron oxides are red, yellow, and black pigments. And they're mixed together. If you mix all of those together, if you remember from 3rd grade, you get brown, right? So that's where we get our tinted sunscreens from. But this study looked at the individual pigments to see which ones were blocking visible light. And it ends up that yellow and red iron oxides, they effectively block ultraviolet light, but they do not block visible light. So if you have a product, for example, an orange sunscreen, if there's no black in there, and it's just red and yellow, you're actually, even though it has iron oxides, you're not going to get protection against visible light. It's specifically the black iron oxides that block visible light. Now, luckily, we don't really use orange sunscreen, although there are a few on the market, interestingly, but we don't typically use those. So almost all of our tinted sunscreens are going to have black iron oxides, but it's important to know that it's the black color that is blocking the visible light in those formulas. And then if you have a combination with black, yellow, and red, and you have brown, beige, all of the shades that we typically see, then you're going to get effective blocking of ultraviolet light, which is what the yellow and red do, and then the black will block the visible light. So I think that's very interesting, and we kind of knew that pigmented products protected against the sun because women who wear a full face of makeup and have been wearing a full face of makeup for decades always have younger looking skin, and likely it's because the yellow and red iron oxides are protecting them against the UV light, and the black iron oxides are protecting them against visible light. And lastly, I just wanted to end with sunscreens. There are some sunscreens that can protect against visible light without iron oxides, and that's with the addition of antioxidants. And Josh mentioned this a little bit in his talk. So look at the 7-day one at the bottom, and you can see the first one is the untreated control that's been irradiated with visible light and long wave UVA. The second one is a broad spectrum sunscreen without antioxidants. So a regular sunscreen that has no antioxidants, even those broad spectrum UVA and UVB coverage, those sunscreens will not protect against visible light, as you can see in that second box. If you look at the third box, that is a tinted sunscreen. That will protect against visible light if it has the black iron oxides, now you know that. And then the last box is a sunscreen that doesn't have any iron oxides, but it has a combination of really potent antioxidants, and it offered some protection against visible light. And this is just the same study, but looking at it a little bit differently. You can see column A is a sunscreen without antioxidants, just plain sunscreen, and you can see that when exposed to visible light and long wave UVA, you can see that increase in pigment. In B, that's a commercial tinted sunscreen, so you see that reduction because the tint, the iron oxides are protecting the skin from visible light, and C is that combination product which doesn't have any iron oxides but it has antioxidants. So in summary, you've learned all about the new treatments for hyperpigmentation. We have tyrosinase inhibitors, but now you know there's a difference between the ones that have been shown to inhibit mushroom tyrosinase versus human tyrosinase. We've seen a new ingredient, 2-MNG, that binds melanin precursors, ingredients that work on melanosome degradation, ingredients that work on inhibiting plasmin, and then these multimodal approaches. And then finally, maybe topical metformin, you can consider compounding that in your clinical practice. And don't forget to protect your patients against visible light. Thank you.
Chris, she's going to speak to us on nutraceuticals for skin health and appearance. So now we're working our way around the exposome wheel, and we are at nutritionals.
Thank you, Zoe. Thank you very much. I want to start with my disclosure. I do work for a nutraceutical company called Nutraceutical Wellness, and at the end of the presentation, I'm going to talk about some data that was generated in a study that Zoe Dralos did on one of their supplements. So when I say the word nutraceutical, you probably think of supplement. You think of minerals and vitamins and herbals, and you think of things that can be used as treatments. These have benefits to the skin. So this is a perfect definition, and I always love these diagrams because I think they capture a lot. But this is the definition of a nutraceutical. And if we look at consumer data, which I always find really interesting, 3/4 of adults in the US take supplements, and most users agree supplements are essential. So if you think patients aren't going to ask you about this, they are. Now I want to spend just a minute or two talking about regulations of nutraceuticals, and I know we have a lot of international here, so regulation, we can only talk about the US, but this is important, and I just want to make a point with it. If we look at regulations, the difference between dietary supplements and drugs, you can see that the biggest difference is in the pre-marketing approval process. When it comes to labeling, mandatory reporting of adverse events, having good manufacturing processes, registering your facility, and advertising claims, we have all the exact same regulations. So what's this pre-marketing approval process? Well, this is probably the most important thing, because this is where, if you're a drug, you have to do phase 1, phase 2, and phase 3 clinical trials. You have to prove efficacy and safety before you can even go to the FDA for approval of your medication. And those take many, many years and lots of money. When it comes to supplements, they don't have to do this type of testing. If your supplement contains all ingredients that are considered GRAS, which is generally regarded as safe and effective, then you don't have to do any studies to get them into the marketplace. If you're using something that's brand new, you have to notify the FDA that, hey, we've got a brand new novel ingredient here. I think you have a 75-day window to notify them of what you're using. But, so what do we do as doctors when we want to recommend supplements? I think the most important thing to understand is that companies are left to their own devices to do studies. And we do have companies that are doing studies, and I find more and more supplement companies are doing rigorous studies. So this is good news, but as physicians, we want to look for studies. Now we're going to talk today about nutraceuticals for treating various inflammatory skin disorders. Everybody is now well familiar with the gut-skin axis, and it's been referred to several times in the talks. We know that what goes on in the microbiome of the gut affects our skin. Now, gut dysbiosis occurs for many, many reasons, but the primary ones are our Western diet, which is a terribly composed diet, unfortunately, alcohol consumption, overuse of antibiotics, which I think sometimes in dermatologists we might be guilty of, and then finally stress. But these are some of the major factors that can influence the microbiome. So what happens when our microbiome goes into dysbiosis in the gut? Well, harmful bacteria cross this leaky gut. They release compounds like lipopolysaccharides, but more importantly, they bind to toll-like receptors on cells and release inflammatory cytokines. These cause chronic gut inflammation as well as systemic chronic inflammation. And all of this inflammation in the general system can influence our inflammatory skin disorders. There's also sort of a more direct connection between the gut microbiome and the skin microbiome. We know when the microbiome is healthy and diverse, short-chain fatty acids are produced by the breakdown of non-digestible carbohydrates, butyric acid, acetic acid, propionic acid, and these have positive effects. They actually have antimicrobial effects, and they have anti-inflammatory effects. Again, when we get those harmful bacteria building up, especially C. difficile, substances are released that impair epidermal differentiation and impair barrier function. So we need a healthy gut microbiome to have a healthy skin microbiome. Now there's been lots of studies, and we're going to talk about some of them, looking at prebiotics, probiotics, and symbiotics for eczema and barrier repair. We know that if we can modulate immune function through the gut microbiome, we upregulate T regulatory cells, those are the good ones, and we modulate that Th1, Th2 balance in favor of Th1, and we also enhance barrier function. Now there are a couple of large systematic reviews and meta-analyses. This is a good one. They looked at 14 placebo-controlled studies. This was over 1,100 children involved. And what they found, and this was for the treatment of eczema or atopic dermatitis, they found that there were single strains of lactobacillus which would improve SCORAD significantly over placebo. Some strains are better than others, and they're in here. It tells you which ones perform the best. And then longer treatment times and starting at a younger age really reduce the symptoms of atopic dermatitis. So this is a nice paper. There are studies on both sides of this issue, so this is a really good way to look at it and a good study. We also have this meta-analysis, which was looking at symbiotics. And for those who don't know, symbiotics are a combination of a prebiotic and a probiotic. And they looked at studies that were looking at symbiotics for treatment as well as symbiotics for prevention of atopic dermatitis. There were 6 treatment studies encompassing 369 kids, ages 6 months to 14 years. They looked at a pooled change in SCORAD and saw at 8 weeks the SCORAD was significantly reduced by a little over 6 points. Beneficial effects were found only when using mixed strains, so this is a difference from the first study. This is looking at symbiotics with mixed strains. And then they found that benefits were only found in kids who were over a year. So this is a really nice, again, meta-analysis looking at this issue. There were 2 prevention studies, so kind of like what Heather said, sometimes there's not a lot of studies to look at. And what they basically saw was that the prevention studies, although they had huge amounts of subjects in them, it was just inconclusive for needing further studies. So this kind of really takes a nice hard look at prevention as well as treatment of atopic dermatitis. Now, we know that essential fatty acids are essential for barrier function, and we know this because we see patients with essential fatty acid deficiency. You're all familiar with the skin changes, and there are many in patients who have essential fatty acid deficiencies. They get cirrhosis, scaling, erythema, barrier dysfunction. They get this kind of white, they call it snowflake-looking scale. And there's lots of other findings as well. But essential fatty acid deficiency is a way that we can look at what happens when fatty acids are deficient. Now, just as a refresher, you have, of course, omega-3 fatty acids and omega-6s. These are called essential because we can't make them, so we have to get them from diet or from supplements. And probably the most important one to understand are that fish oils contain primarily omega-3s. This is EPA and DHA. And that the borage and evening primrose oil, which have been looked at extensively in atopic dermatitis, contain omega-6 fatty acids primarily. So there's not a systematic review or meta-analysis, surprisingly enough, but Peter Leo, who I think is one of the most prolific writers in the business these days, did a really nice review, and it's published just this past month in the journal Dermatitis. I think that what he concluded, what he found was that there are lots of studies on both sides, and if you look at borage oil and evening primrose oil, although they should theoretically work, there are mixed results. Fish oils reduce clinical scores and symptoms of atopic dermatitis, and black currant seed oil, hemp seed oil, and even oral ceramides, which are a little bit off topic, but very interesting, that oral ceramides are promising, but we still need more studies. So this is a very good review article by Peter. EFAs have also been looked at for cirrhosis in healthy subjects, subjects with dry skin, and particularly elderly subjects who we know suffer with cirrhosis, particularly at certain times of year and in certain climates. Evening primrose oil, flaxseed oil, and borage oil mitigate dry skin and itching, improve skin roughness, improve barrier function and transepidermal water loss, and improve skin hydration. And these are some of the references for these studies. This is an interesting study that I always like to quote. It's not a supplement study, it's a whole food study. It's called the NHANES study, the National Health and Nutritional Examination Survey. It encompassed over 4,000 female patients between the ages of 40 and 74. And they assessed their nutrients by 24-hour recall. The dermatologist assessed the patients to see how much wrinkling they had, how much senile dryness they had, and how much skin atrophy they had. And those people who had a higher intake of linoleic acid had less senile dryness and less atrophy. Also, not surprising, high intakes of vitamin C had a lower incidence of wrinkling, so eat your vitamin C containing foods. And then a lower incidence of senile dryness was also seen in vitamin C rich diets. And of course, high fat and high carbohydrate intake was not good for the way skin looked. They had more wrinkling and more skin atrophy. So again, not a supplement study, but I love whole food studies because I think if we just ate better, we wouldn't have to take all these supplements. Now I want to finish by talking about acne. And there are so many acne nutraceuticals coming in the marketplace. They contain things like zinc, which has been shown to improve inflammatory acne, probiotics, which again, once the microbiome and the systemic inflammation gets downregulated, can theoretically improve acne, EFAs, many vitamins, but specifically vitamin D, vitamin A, and niacinamide, which we know lower sebum production. Selenium is also been shown to improve acne. And then finally, green tea extract, which is a very potent antioxidant, one of the most potent, and it of course downregulates oxidative stress and helps with lipid peroxidation that we know occurs around the pilosebaceous follicle. Now this is a very good systematic review looking at the safety and effectiveness of oral nutraceuticals for treating acne. It was published 2 years ago in JAMA Derm, and basically, ironically, there were 42 studies that they ended up looking at after reviewing all of these abstracts. And they only thought that 4 of them were really of good quality. And in those good quality studies, vitamin B, green tea extract, probiotics, and botanicals were, vitamin D, and green tea extract and probiotics and botanicals were found to improve acne. Fair quality studies showed pantothenic acid, the omega fatty acids, and 3 and 6, and probiotics were helpful. So, these findings suggest a possible role for nutraceuticals. I don't think that it's a home run yet. I think we still have a lot to learn. Now, this was an interesting paper that we published about a year ago right now in the Journal of Drugs and Dermatology. And we assembled a group of acne experts. And we pondered the question, is acne a systemic disease? We know very well what's going on at the pilosebaceous unit. But what's going on in the system in a more holistic approach that might be influencing and affecting acne? And we identified 6 factors. Number 1 was stress. We certainly know there are many studies showing that stress exacerbates acne, especially in adult female women. Diet and metabolism, high glycemic index diets, insulin-like growth factor, all trigger acne. The microbiome, again, poor diversity in both the gut and the skin, and overall overgrowth of various bacteria certainly can trigger inflammation. Hormonal, we know our patients with PCOS, obviously they're prone for having acne. Oxidative stress, which as I mentioned causes oxidized lipids and triggers an inflammatory response. And then dysregulation of the immune system. Elevated T cell and macrophage responses in the skin upregulate pro-inflammatory cytokines. So this kind of gives us a new look at acne as a more systemic and holistic condition. The next month, we published another article looking at some natural components that could potentially influence this holistic approach. We're looking at new targets. So for the microbiome, including probiotics like B. subtilis and even postbiotics, such as butyrate. Looking at oxidative stress, lycopene, Sicilian orange, these are all potent antioxidants to, again, mitigate that lipid peroxidation. Holy basil, we talked a lot about adaptogens. This is a stress adaptogen, similar to ashwagandha, which you probably heard of. Maca root is something that a lot of women use and take because it helps to balance hormones after you go through menopause, so to mitigate symptoms of menopause, like hot flashes and the like. People will turn to maca supplements. Immune activation, you can use things like curcumin, which we know balances the immune system, and vitamin D, which we know is low in many acne patients. Those who have low vitamin D get better when we supplement them with vitamin D. And then finally, diet and metabolism. We talked about the role of the glycemic index. So first thing that you think of course, is berberine. But berberine, as well as ginger extract, can have an effect on this influence on acne. So a nutraceutical was created with with all of these ingredients as well as some others, and it was tested in a double-blind placebo-controlled study, and this study was done by Dr. Drelos in her laboratory. It was a big study. It was 100 patients. They were randomized, either active or placebo. They were ages 18 to 50. They were all females, so this is an adult female acne study. To qualify, you had to have mild to moderate acne, at a minimum of 5 inflammatory lesions and 10 non-inflammatory lesions. So these people had significant acne, and it was a 3-month study. They were all put on an active skincare regimen of a sunscreen, a cleanser, and a moisturizer. And there was a washout period, 6 months for oral retinoids, 1 month for prescription acne meds, oral and topicals, and prescription antibiotics, inhaled steroids and hormones, and then 2 weeks for things like light therapy and OTC acne meds. Now you can imagine when you have long washout periods like this, which is, I think, is very generous to do, that there's a lot of people who get worse before they get put on either active or placebo, and I know Zoe experienced that in the study. The main primary endpoint was IGA, investigator graded assessment by a blinded dermatologist. We also looked at acne lesion counts, both inflammatory and non-inflammatory, by a blinded investigator. There were instrumentation done. Skin assessments by the blinded dermatologist also included other parameters of the skin. So does it make skin look better in other ways? They looked at post-inflammatory erythema, post-inflammatory hyperpigmentation, acne scarring, skin tone, smoothness, tactile roughness, and overall skin appearance. So this was a very robust study. So, did we lose the, let me see. I'm sorry, we lost the most important slide, but I'm going to tell you what it says. First of all, investigator grading was statistically significantly improved at 4 weeks in the active group And at 12 weeks, it outperformed the placebo. So the patients taking the active nutraceutical got better compared to placebo. If we look at lesion counts, this is so interesting because the blue line shows you the lesion counts. And they're significantly down at 4 weeks, at 8 weeks, and 12 weeks. In both groups, they're down in the acne group, the group that took the acne supplement, as well as the group that took the placebo. So why is that? Well, it's very interesting because there is a very strong placebo effect when it comes to acne studies. And this was even shown in some of the prescription studies, like the difference study. You know, when you give patients something that they think is gonna make them better, and even if they're on the placebo, a lot of relief happens. I mean, they feel like there's hope and they're gonna get help. So I think this really speaks to the systemic contribution of stress and things like that, that you can see as we get closer to the 12-week time point, it starts to separate out. And you know, study design is always hindsight. It would have been lovely to do this study for 6 months, because I really believe when you're looking at systemic effects and you're looking at nutraceuticals, longer studies are probably better. But I think we have a suggestion here that we're outperforming the placebo, although not statistically significant. So very interesting results. But remember again, the investigator graded assessment was statistically significant, so that primary endpoint was met with the study. Also, interestingly enough, this nutraceutical affected many skin parameters. It affected post-inflammatory erythema, scarring, skin tone, softness, smoothness, and overall skin appearance. So it might make your skin look better in more than one way, which is improving acne. I always love to show before and after pictures. These are, I think, really sort of standard types of types of improvement that they saw during this study. This is a woman, lighter skin type, very nice improvement at the end of 12 weeks. This patient with a darker skin type, and I should have mentioned that all Fitzpatrick skin types were represented in the study, which is nice. She gets a very nice improvement as well, especially looking at the forehead. And then finally, this patient, again with a lighter skin type, it's certainly easier to see the improvement in things like PIE when you look at patients with lighter skin types. So in conclusion, I think supplements are important to consider when treating inflammatory skin disorders. We don't know everything, we haven't connected all of the dots, but I think there's a lot of good data here. Probiotics and essential fatty acids may be helpful for treating both atopic dermatitis and xerosis. Acne may be amenable to nutraceutical solutions that can be used either alone, as was done in this study, or can be used as part of a more comprehensive treatment regimen. And then finally, look for studies. I commend the companies that are doing the double-blind placebo-controlled studies so that we as dermatologists can have confidence when we recommend these products. So Zoe, 1 second. Thank you.
Breaking cosmeceutical concepts, very, very important area.
Zoe. Thanks for hanging in there, everybody. I'm excited to be here. We are going to talk about novel concepts, which is so fun for me because I get to look to the future and see what's coming or what's just around the corner. These are my disclosures. I work with a lot of companies. But most of what I'm talking about today is maybe theoretical or just around the corner. I think it's good for us to just lay the framework about what we're talking about, which is really the hallmarks of aging. Remember, there are, 12 or 13 hallmarks of aging now? And the idea is that we are shifting, like Dr. Grelos mentioned, we are shifting from this anti-aging effect to prejuvenation, right? Holding on to what we have. If you go to the exhibitor hall, which unfortunately is closed, but if you went to the exhibitor hall, you'd see companies that have ways to hold on to the collagen and elastin that you already have. And that's the idea that we are moving towards, where we will start skincare much earlier in life, which will allow us to slow down and prevent many of the signs of aging as much as we possibly can by focusing on the hallmarks of aging. Now, there is a hierarchy of these hallmarks. They're the primary hallmarks, which progressively accumulate with time, and you can see those right here in blue, the primary hallmarks, including telomere attrition, which we're all very used to, and epigenetic alterations, which Dr. Drelos also talked about. Disabled macroautophagy, the idea that the garbage system of your skin is not working well. You can't get rid of that elastotic material, for example. Then the antagonistic hallmarks, which play a more nuanced role. And the idea here is something like antagonistic pleiotropy, where early on, for example, the nutrient sensing network is so important for development. But later on in life, unfortunately, it can lead to, bad things, including the aging process, but also disease. And then we've got the integrative hallmarks, where if you take the antagonistic and the primary and you combine them over time as they build up, they lead to the integrative hallmarks, which if you look here are the ones in pink, and they include altered intracellular communication, chronic inflammation, and you can read the rest. Now, is it even worthwhile, right? Is it worthwhile to start even later on in life? I just talked about prejuvenation, but what about using these products even after prejuvenation? So this was a study in an elderly patient, and obviously that hand on your left was not treated, that was placebo, but the hand on the right was treated, and it was treated with rapamycin, which targets mTOR, mammalian target of rapamycin. So you can see so many of the attributes of rejuvenation we would commonly attribute to ingredients that we use right now. You would think of retinoids and antioxidants and lightening agents. So many different ways to build collagen, and we also see that there's difference in both the epidermal and dermal layers, perhaps even lower than that, as we look at the difference in the volume of that skin. So certainly, while we are targeting the hallmarks of aging, does not mean that we can't induce rejuvenation, and I think we need to overcome that dissonance in our minds. Okay. It is also unusual for us to consider everything in a silo, and indeed, so many of the hallmarks affect each other. Genomic instability, epigenetic alterations, telomere attrition, as well as mitochondrial dysfunction, all leads to cellular senescence. So if all roads leads to cellular senescence, perhaps that is what we should really focus on. So senescent cells. They occur, we all have senescent cells all the time. They're part of our biology, okay? After many cell divisions, their telomere attrition, which I showed you already, is a hallmark of aging. They have a critical short length and cell division ceases. And at that point, your cell needs to make a decision. Either die through apoptosis or go into a state of senescence. And we think about senescent cells almost like zombies. They avoid apoptosis, but they also secrete this horrible panel of inflammatory cytokines. Now, as we age, our ability to clear the senescent cells unfortunately wanes. And so the amount of senescent cells increases, and that senescent-associated secretory profile really does lead to inflammation, and it causes other cells to become senescent. So we need to stop this vicious cycle of aging. How do we do that? There are two different ways. Use senolytics, which are medications that literally take care of the senescent cells. They kill the senescent cells, they remove them, which our body does naturally. We just need to give it some more help as we age. And then xenomorphics or xenostatics, which reduce the inflammation caused by the senescent cells and therefore deal with this vicious cycle of aging. Now, when we think about inflammation, it's due to a couple of different major categories of issues. So immunosenescence, where both the innate and the adaptive immune system becomes impaired, as well as that chronic inflammation that happens in the elderly, where we just have this baseline level of pro-inflammatory cytokines that increases, including our friend IL-6 and TNF-alpha. That leads to damage-associated molecular patterns. I'm just giving you an acronym talk today, apparently. So we have SASP and DAMP, damage-associated molecular patterns. Leaky gut or dysbiosis, Dr. Ferris already talked about that leaky gut and how that can lead to a change in your microbiome, which is what Dr. Drelos talked about. So really, everything that you've learned so far comes to play with immunosenescence, accumulation of senescent cells, and this idea of inflammation is kind of the catch-all terms for what we are all discussing. Now, do senolytics work? Heck yeah, they do. The problem is we don't have any that we can use. BCL2, for example, is the target, but ABT263, ABT737s are both great senolytics, The problem is they cause profound thrombocytopenia, and so we don't have those available. But you can see here, whether the senescence was due to UV, replicative, or hydrogen peroxide, you see that the colored bars are the increasing concentration of the different senolytics, and we can see the number of senescent cells decreases with a higher concentration of these senolytics. Dasatinib is something that is a chemotherapeutic agent that is available, and you can see how it affects senescent cells. So we do see biologically in vivo that we can reduce senescent cells while leaving the senescent cells alone. We can even inject these different compounds, these senolytics, and this is one that was injected into mice. And you can see, even the old mice, we see an increase in the collagen 1. We see an increase in the epidermal thickness. We see an increase in collagen density as well. From now on, I'm only looking at studies that have histopathology, right? Because that's what gives us the most information in my view. And we see what these can do. So again, targeting the hallmarks of aging allow us to achieve what we consider rejuvenation so that the skin appears like it did in a younger state. So let's talk about concepts. I've laid the framework, I feel, and now we're going to talk about concepts. So the first concept to think about is look to nature. And we've already heard in other talks that there's the ability to use supplements to achieve rejuvenation. These are naturally occurring xenomorphics. I know this is a bit of an eye chart, but as you can see, there's plant sources listed for all of these. So these literally are botanical ingredients, and let's look at what they do. So quercetin, for example, affects MAPK, mitogen activated protein kinase. MAPK is super important. It's how the extracellular signals are translated at the cell surface level to affect intracellular communication and processes. In particular, they affect cell growth, cell division, and it's just a very important part of our cell cycle. So MAPK is targeted by quercetin. It's also targeted by resveratrol. mTOR, as I mentioned, by fisetin. Fisetin also decreases the senescent-associated secretory profile. Caffeine, resveratrol, which some of us like to drink instead of taking into a pill. And then curcumin. Curcumin also decreases the number of senescent cells. So there's this idea that we really can't affect the number and the amount of senescent cells by taking these compounds. The question is it too much? Because there may be this idea of a hit and run approach that we need to take with these supplements. There's a few considerations that we need to keep in mind. So in the cell cultures, it takes on average about 4 weeks to establish senescence and the senescent-associated secretory profile. Killing one generation of senescent cells is beneficial to reduce the spread of senescence. We don't have to keep killing and killing and killing every single day because we know senescent cells play an important role in many biologic functions. Therefore, intermittent dosing may solve for safety and efficacy, but we need more trials. So what I tell my patients is if they are doing this, do not take these every day. Take them maybe every second or third day. Now this is totally conjecture. This is based on this idea of these considerations. But I do like the idea that perhaps we need senescent cells in our body for biologic functions. We know that anyway. And reducing them every single day may actually be detrimental to our health. Okay, novel concept number 2. What's old is new again. Let's talk about growth factors. I feel like growth factors are so 1995. But we need to talk about them because, as Dr. Sadik was saying, I'm not sure exosomes are going to last. I'm not sure we're going to see what we want from the exosomes in terms of true clinical studies that prove their efficacy in a large group of patients. Certainly, we all have patients, anecdotally, onesie, twosie patients who have had incredible results with exosomes. I don't care about the source, but just incredible results of exosomes. But thus far, the studies do not show that as topical application on a daily basis, they affect huge amounts of change for skin quality or to rejuvenate the skin. But growth factors, however, are really interesting. So they have a huge size, and this has always been the problem. And I know Dr. Drelos spoke about this many years ago. I'll never forget Dr. Drelos' lecture about growth factors on the skin and how she made a very astute point that they are huge molecules. How could they possibly be doing that much to the skin when they are between 6,000 and 34,000 Daltons? 6,000 is epidermal growth factor, 34,000 is fibroblast growth factor. But they do have some really good cellular processes, affect cellular processes. These include proliferation and migration, improved blood supply. Collagens and extracellular matrices are also induced by growth factors endogenously. They act as signaling molecules, and often because of their size and their poor penetration, they have to be included just as integrated skincare. But let's focus on one, platelet-derived growth factor. And you can see here, when platelet-derived growth factor is released by this little needle, these mesenchymal stem cells, or MSCs, are attracted to it. So the platelet-derived growth factor is causing an increase in MSC proliferation. And indeed, when 23 different growth factors were assessed, it was the platelet-derived growth factor that was the most potent stimulator of mesenchymal stem cell proliferation. And here we see that it can increase collagens types 1, 3, and 6 production, as well as secretion of fibronectin by human dermal fibroblasts after just 2 weeks that were cultured in its presence. We see a 600% increase of collagen type 1, 2,000 type 3, 21. I mean, these percentages we don't see. And of course, this is in vitro, and so I'm not gonna go crazy with this. But the idea is there that we really have the ability to kickstart this increase in collagen and other beneficial aspects of both the epidermis and the dermal matrix with these growth factors. In addition, in skin fibroblasts, 33 growth factors were tested, and it was the platelet-derived growth factor that was the most potent stimulator of collagen and hyaluronic acid as well. I mean, my goodness, this looks like it is truly incredible for our skin. 800% increase in hyaluronic acid production. But again, it's big, right? How are we going to get that into the skin? How do we violate the 500 Dalton rule? That's the rule, right? The 500 Dalton size, as well as a nanometer size of about 5 to 7 nanometers. Beyond that, we cannot get penetration very easily through the stratum corneum, so we need to assess penetration. And there is a professor in Canada that has really done some incredible work. So we know liposomes, multilamellar liposomes as well. There are skincare, very famous skincare companies that use multilamellar liposomes in their products right now, and that's first generation. And they're used to deliver small molecules. Then more technology was used to develop these biphasic vesicles, which are multilamellar liposomes that are able to contain larger molecules within them and help deliver them to the skin a little bit better than liposomes themselves. But now we're at the point with technology that we have what are called multiphasic vesicles, also known as tiered release vesicles, which are super interesting because they interact with the mortar of that brick and mortar system of our stratum corneum to interpolate between the fatty acids and form channels for much larger molecules to penetrate. And that they do this through submicron emulsion droplets. They have micelles in there. They've got multiple mixed phospholipid bilayers. You can see the light microscopy of tiered release vesicles. You can see them there, okay? Very, very interesting. But how they work, again, is they intercalate between the phospholipid bilayer and they cause channels to be produced. And this is at a very high level. Of course, the science behind this is way above my head. But the way I understand it is they form a diamond matrix and they form channels, and through those channels, they allow very large molecules to penetrate. So now we're at the point of perhaps we can get these growth factors or high molecular weight hyaluronic acid to penetrate through the stratum corneum. Here is a great study which shows ethosomes, which are ethanol-containing liposomes. Ethanol at 45%, as you know, is a great penetration enhancer. So this is almost like an active control of ethosomes containing this peptide that they call peptide 1. And we can see with the ethosomes, it really doesn't penetrate very much at all, okay? But that's an active control. And then they have tiered release vesicle 1. They made 2 different tiered release vesicles. And this is also what's so amazing, is that they can fine tune what's in the tiered release vesicle to the ingredient they are trying to penetrate through the stratum corneum. And so the peptide 1, the tiered release vesicle 1 with the peptide, really, as you can see, got great penetration into the epidermis, but then it had a gradient through the dermis. So upper dermis, okay, lower dermis, not so much. And then we get to the tiered release vesicle 2 with this novel technology. And not only did we get epidermal penetration, look at the penetration through the entire dermis, guys. It is even. There's not a concentration gradient from the upper to the lower dermis, as you can see in the graph at the bottom. It's a pretty straight line there. So now we're even seeing that we can penetrate all the way through the upper to the lower dermis. How are we doing this right now? We have to use fractionated laser, we have to use microneedling, we have to use energy-based devices. Now we are at the point of, do we? Do we have to spend $200,000 on a laser anymore? So it's just a change in thinking. And here we have confocal microscopy with both low and high molecular weight hyaluronic acid. And we can see that, yes, the low molecular weight does penetrate through, that's the green. So the 50 kilodalton we see all the way through the dermis. That's a glycosaminoglycan. It's not sulfated, but it's one of the glycosaminoglycans that we have that is a great humectant. And of course it gets through the epidermis as the high molecular weight penetrates through the sternum corneum and gets into the epidermis as well. Historically, we think of this high molecular weight HA as a moisturizer. It just sits on the top and it holds in the water that the skin has. But with this technology, we can get it at least into the epidermal layer and allow it to act as a humectant in the epidermis as well. It's a novel way of thinking about hyaluronic acid as well. Conditioned media, Dr. Sadik mentioned that, so I'll go through this relatively quickly. The idea is you take the good stuff that the stem cells make in culture, which includes growth factors and exosomes and other anti-inflammatory cytokines, for example. And you take that and you apply that to the skin at a very high level. We know adipose-derived stem cells are the easiest to obtain and to culture, okay? So I think moving forward, you'll see companies really focusing on adipose-derived stem cells. This is a company that has a very long history of using conditioned media in their products. And we see control versus what they call their A+. And this is in vivo, ex vivo skin tissue, tested for 5-day application in a 63-year-old female. And we see a reduction in the number of senescent cells. The brown decreases. And then here we see in facial skin treated with A+ serum, this is in vivo, skin type 4, and again we see a decrease in the number of senescent cells. So we are seeing the application of the conditioned media to affect the senescent cells as a xenomorphic here. And we see great data they produced for the proteasome, which is essentially your body's ability intracellular to deal with debris and old proteins, autophagy as well, stemness, the ability of stem cells to renew themselves, connexins, extracellular matrix, epidermal barrier repair, and then as I said, the H&E slides are really important and the stains are really important here. And we see everything that really increases, so the decrease in the elastotic material, the increase in collagen 4 to really reform our basement membrane, and you can go on through that. Then there was another study that was done in Korea where they took adipose-derived stem cells, conditioned media, and they applied it via an airbrush technique to the face, and they used 2 different forms of it. They had the control, untreated control, which is essentially just vehicle. And then they had the 5% adipose-derived stem cell conditioned media, and then they had it in polymerosomes, okay? Polymerosomes are again, it's like nanosomes, okay? It's using nanotechnology to increase penetration through the skin. And while the adipose-derived stem cell conditioned media by itself did improve, as we just showed you, it can improve hydration and luminosity, when it was in the polymerosomes, when it was nanofied, we see that it was statistically superior to that which wasn't in the nanosomes for hydration, luminosity, eye wrinkle size and depth, erythema, roughness. So why were they superior? We usually think about these products kind of getting through the hair follicles, right? Because there's no stratum corneum in the hair follicles, it's probably easier for everything to penetrate there. But if you look at the total surface area of the skin, hair follicles or appendages comprise 0.1% of the entire surface area, and only 0.1 to 0.5% of the total absorption of a topical as well. So when you hear a company says, oh, it gets absorbed, it's a large molecule, it'll get absorbed through the hair follicles, you have to realize that that's technically true, but very little is being absorbed because it's such a low amount of the surface area of the entire skin. So we have to get through the intact epidermis, and that's where those nanosomes or polymerosomes come into play. Now quickly, this is topical sirolimus. I already mentioned this when we looked at the hand. It's already available to be prescribed, right? For tuberous sclerosis patients with angiofibromas, you can get this compound as well. The goal for cosmetic use is not stopping cell growth, but improving cell growth. And we're seeing here P16 as a marker for senescence when it's applied to the skin as topical rapamycin in subjects 40 years of age and older in this 0.001% solution with DMSO to increase permeation. We see that a statistically significant reduction in the number of senescent cells also. So again, this way to target the hallmarks of aging. Look at the basement membrane as well. Okay, so we are seeing the effect of decreasing senescent cells in many different aspects of our skin. And again, just showing you these hands one more time. All right, so I just want everybody to close their eyes for a second. I know this is the end of the day, but I want you to think about the future of skincare. Imagine a world where there's no retinization because we don't need retinoids. Imagine a world where you don't need to buy that $200,000 laser because you get penetration and you may just need microneedling. Imagine a world where you don't need to apply skincare every day because your skincare is so powerful that you don't need to use it every day, and in fact, you probably shouldn't. And that's the Hidden Line approach. We really are moving into a new way of thinking of rejuvenation using these very powerful ingredients. And I hope to be up here in 3 to 5 years. And I hope to be putting laser companies out of business. Because I really think that skincare is going to get there. Thank you so much.
Meet mass market or the fiberglass,